Today's lesson is on rearranging formulas. A formula is an equation that has two or more variables. It's usually thought of as a way of describing a relationship between variables. And one of the things that we're working on is to solve a formula for a variable, which means isolating that variable, getting it by itself on one side of the equation. So we're going to look at a few examples of how to do this, and we're going to use all of the rules that we used for solving equations. So for this first example, P equals 2L plus 2W, and we're solving for W. Um, this is the formula that gives perimeter for a rectangle. Perimeter is two times the length plus two times the width. And if you wanted to do a lot of solving for the widths, if you knew the perimeter and the length, it would be helpful to have the equation solved for the width first. So I want to isolate that width by itself uh, on one side of the equation. So let's first subtract that 2L term from both sides of the equation. So I've got P equals 2L plus 2W, and I'm going to subtract 2L from both sides. So P minus 2L equals 2W. Okay, so now I've got 2W, so the last step will be to divide by 2, so that I've got 1W. So I divide both sides by 2. 2 divided by 2 is 1, so I have W by itself, and P minus 2L over 2. You might like to just see another way that you could write that. You could separate that into two terms. You could have P over 2 minus 1L, because you have 2L over 2, which would give you 1L. So that might be a simpler way of writing that. Okay? Let's look at the second example. We've got A equals pi r squared, representing the area of a circle, and with relation to its radius, and we want to get the r by itself. We're solving for the radius. So if I've got A equals pi r squared, remember that's pi times the radius squared. To get that r squared term by itself, we'll divide both sides by pi. So I've got now A over pi equals r squared. So to get the radius, I'm going to have to take the square root of both sides. So the square root of, capital A over pi equals r. And I'm okay with you flipping that around and writing that as r equals the square root of A over pi. Okay, so you remember you have to just reverse the operations that are happening. So to whatever's happening to the r. So the r squared term is multiplied by pi, so we divide to isolate it. The r is squared, and the inverse operation of squaring is to take the square root, so that we can get what 1r is. Our third example is a simple interest formula where the amount or the future value is equal to the principal plus the principal times the rate times the time. And it says solve for P, but let's first solve for T. Okay, so I want to get that T by itself. So I've got A equals P plus PRT. I want to get the T by itself, so let's first subtract this P from both sides. So I've got A minus P equals PRT. This is P times R times T. So I can, in one step, I can just divide by PR. Okay? And PR divided by PR is 1. So now I'm left with 1T. So T equals A minus P over PR. Just a little side note, whenever you work with formulas, don't change the case of the letter, because in this case the capital A represents amount or future value. The capital P represents principal. The lowercase r represents the rate of interest and T is time. If you put a capital T in, capital T is often used for temperature. So it's very important to stick with the same form of the letter as you receive in the formulas. Question 4 is the cost to rent a car, which is given by C, is C equals 25D plus 24, where D is the distance driven in kilometers. So how much will it cost to rent if you drive 150 kilometers? And you've seen questions like this, particularly part A, already earlier, where you substitute and solve. So we can say that C equals 25 times 150, because distance represents the kilometers, plus 24. And let's think about what that will be. That'll be, use your calculator. I forgot my notes to bring down to do that. But you can then just enter in your calculator. And do you know what I'm missing? Is a decimal place here. It's okay, it's 0.25 times 150 plus 24. So use your calculator to do that. And again, because the answer is cost, put in dollars and 2 decimal places, okay, for your final result here. And then let's look at question B. How far have you driven if the cost is $72? So there's two ways that you could do that. One would be just to put the cost in at $72 equals 0.25D plus 24. And then we could work to get D by itself. So we'll subtract 24 from both sides. 72 minus 24 is 48 equals 0.25D. And then we'll divide both sides by 0.25. And I believe you'll get 176, but that's something to verify with the calculator because I forgot to bring my notes down with my solutions. So we end up with D equals 176. So you drove 176 kilometers. So if you only needed to answer one question, like B, where you are substituting and then isolating for D, this is a very straightforward way to do it. However, you might also choose, if you needed to answer a lot of them, you might choose a different method. You might say, well, C equals 0.25D plus 24. You might say, well, since I know the cost but don't know the D, the distance, I might isolate the D first. So if we rearrange this formula so that D is by itself, we would subtract 24 from both sides. So we'll have C minus 24 equals 0.25D. And then we'll divide both sides by 0.25. And we can then say that D equals C minus 24 divided by 0.25. So now we have a little formula that gives us the distance based on the cost, and we could substitute the the cost for the day and solve for distance in one step. So if you needed to do a lot of questions of this sort, it may be easier to rearrange the formula first. And that's the lesson.